In this video, we're going to be solving one-step addition and subtraction equations. Now, in the last video, all we did was determine if a number was a solution, and now we're going to take it a step further by actually learning methods to find the solution when we don't know what it is. So our essential questions are, what is the addition and subtraction property of equality, and how do you use the addition and subtraction property of equality to solve equations? So what is the addition and subtraction property of equality? Well, this property says that if you add or subtract the same amount from both sides of an equation, it will still be equal. So what you do to one side of an equation, you have to do to the other in order to maintain equality. So I have a couple examples here of using the addition and subtraction properties of equality just to show that it does hold true. Here I have a statement that is true. 4 plus 6 is equal to 10. Hopefully we can all agree that that is true. Now the addition property of equality says I can add whatever I want to both sides of this equation and it will still be equal. So I just picked a number. I picked 5. So I add 5 to both sides of this equation, 4 plus 6 plus 5, and 10 plus 5. I did the same thing to both sides of this equation. And if I evaluate both sides, I get 15 on the left and I get 15 on the right, and voila, these are both still equal. That's the addition property of equality. It says you can add whatever you want, but as long as you add the same thing to both sides of the equation, it will still be true. And the same holds true for subtraction. So I took the same equation that I started with, 4 plus 6 equals 10. And now I'm going to subtract something from both sides. And again, I just kept it 5. So if I subtract 5, I have to subtract 5 from both sides of this equation in order to keep it true. So I have 4 plus 6 minus 5, which is 5 if you evaluate that, and 10 minus 5 is 5. So surprise, surprise, we get the same thing. So that's a basic property of math, that if you do one thing to one side of an equation, you have to do the exact same thing to the other. Otherwise, it's not going to be equal anymore. If we were to just subtract 5 from one side of this equation, we would get 5 equals 10 or 10 equals 5, which is not true anymore. So what you do to one side, you have to do to the other, and it will still be true. So how can we use this property to our advantage when we're trying to solve an equation? Well, we can do this by kind of eliminating terms that we don't want in our equation to find the solution. So we can use the addition and subtraction property of equality to make the term that's on the same side as the variable equal to 0. So basically, we want to undo what's happening to our variable in order to solve it. So I give an example of an equation here. X minus 12 equals 20. Now, you might be able to solve this with mental math, but I just want to show you the mechanics of how this works. So what I want to do, what my goal is I want to figure out what x is, just x. But I know that x minus 12 is 20, so I want to kind of get rid of this pesky minus 12. I want to get just x alone. So how can I get rid of a minus 12, subtracting 12? Well, what would undo that? What would be the operation that would get rid of a subtracting 12? Adding 12. So the opposite of subtracting 12 is adding 12. So what happens if I add 12 to both sides of this equation? Well, if I add 12 to the left side, x minus 12 plus 12, these two basically cancel each other out. Subtracting 12 and then adding 12 makes that 0. So that becomes 0. So all I have left is just x on this side. Well, if I add 12 to the left side, I have to add 12 to the right side. And 20 plus 12 is 32. So here I get a statement that must be true. X alone is equal to 32. So now I found the solution. X is 32. And if you check that and you plug 32 into the original equation, 32 minus 12 equals 20, and 20 equals 20, that checks out and it is true. Now that might seem like a long process for doing something that you might think you can do mentally, but this is going to pay off when we get into more complicated numbers, how to directly find the solution to things that we can't do mentally. So I'm just using simple examples here to help us kind of use training wheels to get to some more complex numbers and numbers that we can't do mentally. So the next one, I'm going to use the subtraction property of equality to show that this still works. So k plus 17 equals 40. What plus 17 equals 40? Again, you might be able to do this mentally, but I'm just going to show how using the subtraction property of equality would work here. So again, I've kind of divided my equation into its two sides so you can see what I've done to both sides. Now what I want to do is I want to get rid of this adding 17. I want to get rid of that so my k is just all by itself so I know what just k is. So what's the opposite of adding 17, or what would undo adding 17? Subtracting 17. So if I subtract 17 from both sides of this equation, it'll still be true. And what happens on the left side here? K plus 17 minus 17. This plus 17 and this minus 17 cancel each other out, and that's just 0. So all I have left is just K. So K is left on the left-hand side, and when I subtract 17 from the right-hand side, I get 23. So K equals 23. That's my solution, and if I check it, I put 23 back in the original equation. 23 plus 17 equals 40. Turns out that is the solution. So that's how we can use the addition and subtraction property to directly solve equations. So let's look at this in practice here. Again, I'm going to use some simple examples, and then we'll get into some more complicated numbers just so we can get used to this. So the first thing I'm going to do here is just kind of cut my equation into its two sides so I can keep track of what I'm doing to each side so I don't accidentally do the same thing to one side twice. So here I want to get y by itself. I want to get y all alone, so I need to undo this. This is what's happening to y plus 6. Well, what's the opposite of adding 6? Subtracting 6. So if I do y plus 6 minus 6, these two would cancel each other out. Well, what I do to one side, I have to do to the other, so I have to subtract 6 from the right-hand side as well. So you can see I've done the same thing to both sides, taking 6 away. So y plus 6 minus 6 is just y, because this becomes 0. So y equals 9 minus 6, which is 3. And if I check that, I put 3 in the original equation in place of y to see if it is a solution. 3 plus 6 equals 9. 9 equals 9. There is my solution. So that's a direct solution. Again, you may be thinking this is a waste of my time because I can do this mentally, but we'll see some cases here in just a minute where that is not the case. So again, I'm going to solve this equation here, 5 equals g minus 4. I'm going to cut my equation into its two sides. Now I'm focused on the side that has the variable g. G minus 4. I'm taking 4 away from g, but I want to undo this. I want to get rid of this term that is with the g. So what's the opposite of subtracting 4? That would be adding 4. So what I'm going to do is add 4. 5 plus 4 is equal to g minus 4 plus 4. I'm going to add 4 to both sides of this equation. This is 9. And g minus 4 plus 4, again, these two terms cancel each other out. That becomes 0, and all I have left is g. So 9 equals g is my solution, and if I check that, 5 equals 9 minus 4. 9 minus 4 is 5. 5 is equal to 5. That is the solution to this equation. So again, using addition and subtraction to undo the operations that are happening in this equation. So let's take a look at some that may not be mental math. Now we're going to throw some negative numbers in here. A minus 12 equals negative 20. Now, this becomes more difficult to do mentally. It's hard to kind of think, well, what does A have to be to make this true? And this is where our addition and subtraction properties really come in handy. This is where you have to know how to do this. So again, if I cut my equation into its two sides, I want to get A all by itself. Well, it has this term with it, this minus 12. I'm taking 12 away from A. So what's the opposite of taking 12 away? Adding 12. So I'm going to add 12. Now notice I'm rewriting everything on every step. Now our temptation is to do a lot of this mental math, but you have to get in the habit of writing this stuff down. Otherwise you're going to lose track of stuff. Like right there, I almost lost track of my negative while I was talking. So here is my next step. Please write each step out. Otherwise you're going to lose track of stuff. And again, trying to do these types of problems mentally is only going to cause errors for a lot of you. So I'm adding 12 to both sides because this is going to make this cancel out. That is going to be 0. So all I have is A, and negative 20 plus 12 is negative 8. So here's my solution. A equals negative 8. And if I check that, plug negative 8 back into that original equation, negative 8 minus 12 equals negative 20. Negative 20 is equal to negative 20. And that checks out. So again, when we have negatives involved, you have to know how to use our addition and subtraction properties of equality. Next one, first thing I do is divide my equation into its two sides. Now I always focus my attention to the side that has the variable because that's what I want to get all alone. So here I want to get j by itself, so j plus 5. So I want to undo this plus 5. And what's the opposite of adding 5? Subtracting 5. So I'm going to subtract 5 from both sides of this equation. J plus 5, I rewrote everything, and then put the minus 5 on both sides. So I have negative 13 minus 5. Negative 13 minus 5 is negative 18. And that's going to be equal to j plus 5 minus 5. And again, these cancel out. That's the whole point of doing that. That goes to 0. So all I have is j, and there's my solution. J, or negative 18, is equal to j, or j equals negative 18. And if I check that, just to be sure, plug negative 18 back in for j. Negative 18 plus 5 is negative 13. So I have negative 13 equal to negative 13, and that is the solution. A couple more. Negative 3 equals a minus 23. Again, my attention is focused on the side with the variable. That might be the left or the right side. So here I'm looking at the a, and I am subtracting 23 from it. So I need to use the opposite operation to cancel that out. I want to cancel out the subtract 23. How do I do that? I do that by adding 23. So I'm going to add 23 to both sides of this equation. And notice again, I rewrote everything, and I'm adding 23 to both sides. On the left-hand side, negative 3 plus 23 is positive 20, and that's going to be equal to a minus 23 plus 23. And again, these two terms cancel each other out. That's 0, so all I have is a. So negative 20 is equal to a, and there's my solution. And again, just to be sure, I'm going to check that. Negative 3 equals 20 minus 23. So negative 3 equals 20 minus 23 is negative 3. That checks out. I know I have the solution. So just take the extra couple seconds to check your solution to make sure that it is correct. Last one, z plus 15 equals negative 83. Again, my first step is to divide this into its two parts here. Kind of divide it down that equal sign. And I'm focusing my attention on the side that has the variable. Z plus 15. So I want to undo the adding of the 15. So what is the opposite of adding 15? That'd be subtracting 15. So I'm going to rewrite that and take away 15 from the left-hand side. That means I have to take away 15 from the right-hand side as well, always tacking that on the right-hand side of each side. And then here on the left, these two terms are going to cancel each other out. That becomes 0. Z plus 15 minus 15 is just z. And negative 83 minus 15 is negative 98. So z equals negative 98. And again, if I check that, negative 98 plus 15 is equal to negative 83. And if I check to make sure that this is true, negative 98 plus 15 is negative 83. These are still equal. That is the solution, and I'm done. So please make sure that you're writing these out. When we start solving equations, the time for doing all of that in your head is over. You've got to get that paper out and write those equations down and show those steps. It's only a one-step equation. It doesn't take much, and it'll save you a lot of heartache in the end.